Hello everyone, in this theoretical tutorial number 36 we will review the main discovery in the solid-state electronic and thermionic emission with the Edison effect, the galena crystal, the thermionic emission principle, the Fleming diode and its first usage. Today we use the term semiconductor for the solid-state electronic, but guess who used this term first in 1782? Again, we come back with Alessandro Volta. I open a parenthesis to remind that Coulomb's law is in 1785 and Volta battery in 1800. I close the parenthesis. So, Alessandro Volta in 1782 used for the first time the term semicoibente in Italian, which means semi-insulating. It was later translated in English as semiconductor. But the term semi-insulating used by Volta is closer to the reality because the pure silicon at room temperature is an insulator. The pure silicon needs to be doped to be able to conduct electricity. 51 years later, in 1833, another well-known guy, Michael Faraday, noted that the electrical resistance of the silver sulphide was decreasing with the temperature. Usually, the metal resistance increases with the temperature due to the increasing atom vibration. But as the semiconductor is initially an insulator, increasing the temperature creates free electrons to conduct the electricity, so the resistance decreases. So Michael noted a semiconductor effect. Again, in this slide we find Volta and Faraday. Both of them was part of our family photo in the theoretical tutorial number 35. 41 years later, in 1874, Ferdinand Braun, probing a galena crystal, lead sulphide, with a point of a thin metal wire, noted that the current was flowing in one direction only. So he discovered the electrical rectification. As you notice, this slide has two columns. Until now, we just filled the left column dedicated to the solid-state electronic. But in 1883, Edison found a new component which passed the current in one direction only. But we will see on the next slide that this new component uses the thermionic emission in the vacuum tube. The right column is dedicated for the invention using the thermionic emission. In 1901, which means 27 years after Ferdinand Braun, Chandra Bose was using the cat whisker where a point contact with the galena crystal to detect radio waves. 3 years later, in 1904, Fleming developed the two-element vacuum tube known as the diode, using the thermionic emission. The common point on all those discoveries is related with a new component able to pass the current in only one direction. It was the first electronic component and it brings a revolution in the signal processing as a radio wave detection. The beginning of the electronic development, oscillator, radio, etc., was using the vacuum tube based on the thermionic emission. The vacuum tube will be replaced in the future by the development of the solid-state electronic. But it is interesting to notice that for the first electronic component, diode function, both in the domain solid-state and thermionic emission was existing almost at the same time, the point contact galena and the Fleming diode. Edison is really famous for the incandescent light bulb he presented in 1879. But in fact, Edison is not the inventor. The incandescent light bulb was invented by Joseph Swan around 1860, but it was not really usable because it was able to work for only 40 hours. Edison was a hard worker. He tried more than 1,000 different filaments for its lamp, until he found a long-lasting filament by using a carbonized bamboo. With this new filament, it brings the lamp life from 40 to 1200 hours, so 330 times longer than the initial Swan invention. At this time, Edison was using a DC generator, so the lamp was biased in DC with a ground and positive side. In 1880, Eimer, an assistant of Edison, noticed a dark spot near the positive lamp terminal. Originally called Eimer's phantom shadow, Edison, his employer, renamed the phenomenon Edison effect. Even if Edison renames the effect found by Eimer, as Edison was a hard worker, he did several experiments to understand this dark spot. He placed a metal plate inside the bulb, separated from the filament. Edison found that when the plate was biased at a positive voltage compared to the filament, and if the filament was heated enough, he could measure a current flowing in the plate. But no current was present if the plate is biased in negative compared to the filament. In 1884, Edison patented this effect without finding a practical usage, but in fact, he discovered the thermionic emission. To analyze the thermionic emission, we need to place two electrodes in a vacuum tube. One electrode is a cathode and the other one the anode, which is a plate. On the bottom right, we have a symbol of the diode with the cathode, the anode, and the heater resistor to warm up the cathode. The minus sign represents the electron in the cathode. Of course, there is the same quantity of positive charges, but only the negative ones, the electrons, are represented because it is the only one we can move. If the temperature of the cathode is less than 730 degrees C, we will not get any anode current. If the temperature becomes higher than 730 degrees, due to the thermal agitation, some electrons will get out of the solid, means the cathode, and stay around the solid in the vacuum. Typically, the vacuum tube was around 1800 degrees with its characteristic orange color. Now, if the plate is negative biased compared to the cathode, the electron will be pushed back to the cathode. But if the plate is biased positively compared to the cathode, the electron in the vacuum will be subjected to the force F equal minus QE, so the electron will move in the plate direction. So the current in the diode is only possible when the plate is positive and current is blocked when the plate is negative. The one-way current direction is just due to the dissymmetry between the temperature of both electrodes. Here we have on top both pictures of Fleming diode in 1904 and 1919. On the bottom we have the Marconi receiver radio using two Fleming valves in case of one fail. At the beginning of the radio we used only the emitter in on or off position, so we could only transmit Morse code, but to do that we need to detect the radio signal. On the top, without a rectifier element, after just a low-pass filter, the signal is always at 0. But with the rectifier element, we just pass the positive signal, the negative part is removed. After the signal processing, the low-pass filter will detect when the high frequency is present, so we can detect the radio waves. During the night of 14 to 15 April 1912, the Titanic sent a SOS. Fortunately, the diode was existing and another boat received the radio message and went to the Titanic. But everybody knows that it was too late to save all the passengers of the Titanic. But without the diode invention, it would have been worse. I want to thank you for your attention. On my next DRC car tutorial number 37, we will talk about the triode, which is the second electronic component after the diode. able to amplify a signal, and if we are able to amplify a signal, we are also able to do an electronic oscillator at higher frequencies than the rotating machine. So see you soon and stay tuned.